Hey everyone, welcome back to Science for Everyone with Tom Copeland. I'm Tom Copeland. Let's get down to science. So today we are talking about how to balance chemical equations. So there's lots of different types of chemical reactions, and I already have a video on that if you want to check that out. But right now we're going to focus on balancing chemical equations. So first of all, the left-hand side of a chemical equation is the reactant side. This arrow is going to signify that a chemical reaction occurred, and then the products are going to be on the right-hand side. So we have barium, we have sulfide, and then that forms a compound, barium sulfide. So I'm going to show you something called an ARP chart. And this ARP chart is really going to help you learn how to balance chemical equations. Let's check out this ARP chart. I already filled it out for you. So A is all of the atoms that are in the chemical equation. So we have barium and we have sulfide. R is for the reactants, and it's the number of atoms that are on the reactant side. So we have one barium. There's not a subscript there, so you assume that that is only a 1. Sulfur, we have a subscript of 8, so we have 8 sulfur atoms. Now the product side, we only have 1 and 1 of barium sulfide. So you need to have this balanced out because the conservation of mass and energy law, you can't just lose atoms. You have to have those atoms accounted for, right? So this is what you need to do. You need to rearrange your ARP chart so that your numbers all are equal to each other for each entry. So barium right now has 1 and 1. Barium is currently balanced. Sulfur is not. Sulfur has 8 and 1. Now the only way to balance out sulfur, there's only one option. That is to put an 8 in front of the barium sulfide. So now that has balanced out the sulfur, but if you notice, that unbalanced the barium. So now we need to take a look at the barium. Now the only number or coefficient you can put in front of the barium is an 8. So if you end up with 8 bariums, you have to start with 8 bariums. So this would be the final balance equation, and this is important. You can only put those large coefficients in front of the element or in front of the compound. You can't add a subscript because that's going to change what that compound is. Okay, let's look at this next one. We have aluminum plus iron oxide, and then that forms iron plus aluminum oxide. If we look at our ARP chart, oxygen is currently balanced. So we're not going to start with oxygen because it's already balanced. So you can either pick aluminum or you can pick Fe to start to balance. Now, if we look at iron, we have Fe2. The only coefficient you can put in front of the iron is a 2 to balance that out. So now we have 2 Fe's. The oxygen is still currently balanced. We have 3 and 3. Now, aluminum over here, we have Al2. The only coefficient you can put in front of aluminum is another 2 to balance out that equation. So this would be the balanced equation for this example. I'm going to show you one more, and then I suggest pausing and seeing if you can work this one out on your own. So we have iron and we have chlorine as the atoms. We have 1 Fe in the reactant side, 1 Fe on the product. But if you look at Cl, we have 2 on the reactant side and 3 on the product. So you want to start by trying to balance out the chlorine. So this is a point that I would encourage you to pause it and try to figure it out on your own. Okay, hopefully you paused it and worked this out. So let's look at it. You needed to get the Cl balance. 2 and 3 have 6 in common. So if you put a 2 here, that multiplies the chlorine because you actually have 2 of these compounds or 2 of these molecules. So you actually have 6 Cls. And over here, if you put a 3, you also have 6 Cls. So that balanced out the chlorine, but by doing that, by putting this 2 here, that unbalanced the Fe.